Elements are classified as metals, nonmetals, and metalloids. Physical state. Generally, metals exist in solid state at room temperature. Mercury is the exceptional metal which exists in liquid form at room temperature. Non-metals exist in all three states: solid, liquid, and gas. Metals are lustrous in nature. Let's prove this by doing an activity. Take a brick or a piece of gold and sulfur and place them in a dark room. Switch on the light. When light falls on the gold and solid sulfur, you will observe that gold shines while solid sulfur does not. Hence, we can conclude that metals are lustrous in nature while non-metals are non-lustrous in nature. Metals are usually hard and are very strong. Hardness varies from metal to metal. A metal like sodium is soft and can be easily cut with a knife, while aluminium cannot be cut with a knife. So, metals are generally hard, but a few metals like sodium, potassium, etc. are exception. Malleability and ductibility. Metals are malleable and ductile in nature. Let us do an activity. To show this, take an iron block and strike on it with a hammer. You will observe that iron changes into sheet. This property is called malleability. Copper changes into wire by doing some mechanical work. This property is called ductibility. Non-metals do not show malleable and ductile nature. Examples are coal and sulfur. Malleability of materials. Let us do an activity to demonstrate malleability of materials. Take a small iron nail, a coal piece, a piece of thick aluminium wire, and a pencil lead. Beat the iron nail with a hammer. Try to hit it hard. Now hit hard the aluminium wire. Now repeat this activity on the coal piece and pencil lead. You will observe that the iron nail and the aluminium wire get flattened on hammering, while the coal piece and the pencil lead break into pieces. Thus, the property of materials by which they can be beaten into thin sheets is called malleability. Notice, when your mom cooks food in a metallic pot in the kitchen, when cooking, when she touches this pot with open hand, her hand gets burnt. Why this happens? Metals are good conductors of heat. When you cook food in an insulator pot, no one is injured. Electrical conductivity can be explained with the help of the following activity. Set up our simple electric circuit as shown here. Hold a piece of copper metal with the help of crocodile clips between the terminals A and B. The bulb glows. Repeat the experiment with a piece each of iron and magnesium. Take other metals as your choice, one by one. You will observe that bulb glows in each case, but the brightness varies. Thus, we can conclude that metals are good conductors of electricity. Electrical conductivity of materials. Let us do an activity to demonstrate electrical conductivity of materials. Set up a simple electrical circuit as shown here. Take some materials such as an iron rod, sulfur, piece of coal, and copper wire. Hold the iron rod with the help of crocodile clips between the terminals A and B. The bulb glows. Repeat the activity with sulfur, coal piece, and copper wire one by one and observe. You will observe that in case of sulfur and coal piece, the bulb does not glow, while in case of copper wire, it glows. This activity shows that iron rod and copper wire are good conductors of electricity while sulfur and coal peas are bad conductors of electricity. A peon strikes a metal with a hard surface in the school for ringing the bell. Metals produce sound when they are hit with hard objects. Thus, metals are said to be sonorous. Take a strip of magnesium and clean it with sandpaper. Hold it with a tong pair or a holder. Bring it in contact with the flame of burner and let it burn. Collect the ashes formed and dissolve them into water. Test the resultant solution with both red and blue litmus paper one by one to check whether it is acidic or basic. You will observe that red litmus paper turns blue. Thus, magnesium oxide is basic in nature. Metals react with oxygen to produce basic oxide. Reaction with oxygen. Rusting. When iron is exposed to moisture, it corrodes readily and gets covered with a brown flaky substance called rust. Chemically, rust is hydrated iron oxide, Fe2O3 2H2O. The reaction takes place as. Similarly, when a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green layer is a mixture of copper hydroxide and copper carbonate. The reaction takes place as. Nature of metal oxide. Take 1 spoonful of rust in a beaker and add some amount of water in it. You will observe that the rust remains suspended in water. Shake the suspension well. Now, test the solution with red and blue litmus paper. You will observe that red litmus paper turns blue, while the blue litmus paper remains as it is. Thus, we can conclude that the solution is basic in nature. This activity shows that the oxide of iron is basic in nature. Collect samples of a few metals like sodium, magnesium, iron, and copper. Put small pieces of these samples separately in a china dish having cold water. Add the metals in cold water one by one. We will observe that sodium reacts with cold water. The rest of metals do not react with cold water. Similar activity is performed in hot water. Magnesium reacts with hot water and the rest of the metals do not react with hot water. In case 1, take a hard glass wood soaked in water. Now put iron wire and heat the test tube. Iron reacts with the steam. A gas evolves. Bring burnt matchstick, it burns with a pop. We conclude that hot iron reacts with steam to produce hydrogen gas. In case 2, repeat the experiment with copper. Hydrogen gas is not produced. Reaction with water. Let us do an activity to demonstrate the reactivity of metals with water. Take a 250 milliliter beaker. Fill it up to half with water. Cut a small piece of sodium metal carefully. Dry it using filter paper and wrap it in a small piece of cotton. Put the wrapped sodium piece into the beaker and observe, keeping away from the beaker. You will observe that the sodium reacts vigorously with water. Now touch the beaker after completing the reaction. It becomes hot. Test the solution with red and blue litmus papers. You will find that the red litmus paper turns blue while the blue litmus paper does not change. This test confirms that the solution is basic in nature. By this activity we can conclude that metals react with water to form bases. Take a test tube containing a piece of sodium. Add 5 milliliter of dilute hydrochloric acid with the help of a dropper to test tube from a bottle. Bubbles come out of the tube. Bring a burning matchstick near the mouth of the test tube. Gas burns with a pop sound. It shows that acids react with metals producing hydrogen gas. Reaction with acids. Let us do an activity to demonstrate the reactivity of metals and non-metals with acids. Take samples of magnesium ribbon, aluminium foil, iron filings, peeled copper, charcoal powder, and sulfur powder in separate test tubes and label them as A, B, C, D, E and F. Add 5 ml of dilute hydrochloric acid to each test tube one by one using a dropper. You will observe that some gas is evolved in the test tube A, B and C while none in the rest. Now bring a burning matchstick near the mouth of the test tube A, B and C. The evolving gas burns with a pop sound. The test tube D, E and F do not evolve any gas because they do not react with the acid. This activity shows that some metals react with acids to form salts and give out hydrogen gas, while the non-metals do not react with acids. Take a test tube containing a fresh solution of sodium hydroxide. Add a piece of aluminium foil using a spatula into it. You will observe that a bubble formed in the test tube. Bring the burning matchstick near the mouth of the test tube. Gas burns with a pop sound. We conclude that metals react with base to produce hydrogen gas. Take 4 beakers half filled with water and label them as A, B, C and D. Add A mixture of compounds of copper sulfate and zinc granules, copper sulfate and iron nails, zinc sulfate and copper turnings, iron sulfate and copper turnings, stir the solution in each beaker and keep the beakers undisturbed for some time. You will observe that in beaker A and B, blue color of copper sulfate solution disappears and a powdery red mass of copper is deposited at the bottom of the beaker. We conclude that A more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive metal. Zinc and iron are more reactive than copper. Uses of metals. Metals like copper, aluminium are used to make electric wires since they are good conductors of electricity. Some metals such as zinc are used for galvanizing iron as a protective layer against rusting. Metals such as aluminium, copper and iron are used to make utensils. Mercury is used in thermometers. Metals such as silver, gold and platinum are used to make jewelry. Nickel and chromium are used for electroplating. Metals being very hard and strong are used as building materials.